Good afternoon, everyone. Welcome to our pre-lab lecture. Today's experiment is on types of chemical reactions and copper cycle. Types of chemical reactions. We started looking at types of chemical reaction in experiment number 4, chemical reaction 1, chemical reaction 2, and also we will see in chemical reaction 3 types of chemical reaction. There are about 7 types of chemical reaction. You should be able to state those and be able to classify. For example, when we talk about combination reaction, decomposition reaction, 3, single replacement reaction. 4, double replacement reaction or metathesis reaction. There is acid-base neutralization. There is a redox reaction, all right? And there are 2 types of reaction, even though it fall under other types of reaction, and these are combustion reaction and cars forming reaction. In relation to copper cycle, when taking copper around, through a circle, we will have to encounter those types of reaction. Let me share my screen here. You will need to read. You need to read the background in TopHat before you. All right. Before you attempt to complete the data sheet. This is experiment number 9 in the lab manual at TopHat, all right? Types of chemical reaction and copper cycle. These are not the only types of reaction when we look at. There will be series of chemical reaction. There are chemical equations in the lab manual from number 1 through 13. You need to refer to those chemical equations. They are numbered, all right? Number 1, number 2, all the way to number 10, number 12 or 13. It's 13 right here. This is the last one. There is chemical reaction 1, 2, 3, 4, all the way to 13, which you should be able to see. All right. This is reaction 4. There is reaction 1. Let me show you the relationship between all those types of reaction. This is reaction number 1. All right. Reaction number 1. But in classification, to say that this is copper, we will start with for copper cycle the reaction between copper. This is where the copper start from. Introduction to this is reaction 8. If you look at the starting point, right? We start with copper as the reagent. Pay attention to what? To the physical state of the reagent. And the last one, let me fast forward to, you see, this is the first one reacting with nitric acid. If I fast forward to the last equation, which is equation 13, you'll see that copper is the is the last, or is one of the product in the last equation. This is equation 13, and equation 13, and by now you see where copper is. Copper is product. It is formed at the end. In between, copper is in form of other compounds, which you have to keep an eye on. So think of it as, where is copper as we take it up. Along this circle you see here, you need to be able to keep an eye where copper is. For example, we start off with copper here, all right? We will take it around a circle until we come back to the same position. So we'll start with copper and end with copper. In the long run, you'll determine the mass percent of copper recovered, all right? by mass percent, you will have to use the equation mass, all right, mass percent is given by recovered what? That is the mass at the end, recovered copper. This is recovered copper in grams, recovered copper in grams over what? Over the original, the static mass of copper. You should be able to have these data once you collect the data. You will have this information. You will need original mass. This is original mass in grams times 100%. This is the ultimate goal or objective for this lab is what is the mass percent of the recovered copper once you take through the cycle. Here, you see copper is in form of another compound here. You'll be stating, keep an eye on where copper is. Look at what I'm circling. Look at what I'm circling. In this circle, it doesn't state, all right? It doesn't state whether copper is in aqueous form, whether it is in liquid state, whether it is in gaseous state. You got to be able to look at the equation. For example, in the last equation here, equation 13, copper is in form of what? It is in form of solid state. I know it is solid. You know, when S is used, it means the reagent or a compound is in solid state. Aqueous means it is aqueous. Liquid, all right, is designated using L in a chemical equation. You will be able to do that. Let's see the data sheet. How you will complete. You got to come to this circle and refer to equation A through equation 13 to be able to complete the data sheet. Here is the data sheet. Let me just clear this and make sure it's not hard. I'm just going to clear this and see how we will complete this. Cars forming reaction. All right. In this table here, table 4.1, 4.2, and I think 4.3, you'll have to keep an eye on where copper is. To do that, there is a PowerPoint. There are PowerPoint slides posted on our Canvas, which you need to use those slides as well to do it, to be able to exit this, and we'll see the type of reaction here. Let me just enlarge this and show you cars forming reaction. You got to watch the simulation on the PowerPoint slide on Canvas for each cycle. So when you look at slide number 1, all right, slide number 1 here, you are given the mass of empty 100 ml beaker and the mass of the beaker with copper. This information here you should be able to use to find the mass of copper used in this cycle, in this experiment. This is the original mass. So if I was to use these numbers here, this will give you original what? Original, the starting mass of copper, the starting mass of copper. You have to use the information given here. Once you fill in the information, all right, you will have to do the calculation. Watch the simulation. What is, if I look at the color of the solution, not before the reaction, that is after the reaction on experiment or table 4.1, you will now fill in the table. Why this? So if I were you, I'll have to look at the look at the what? Look at the simulation. I'll pay attention to the equation on top here so that to do the mass of copper, I'll have to find that. That is what we will use in determining the mass percent of the recovered copper. This table right here should be completed after the reaction on 4.1. After performing the experiment, you have to ask yourself, in which state is copper? Is it solid state? Is it in liquid state? Is it in aqueous state? You have to look at what? You have to keep an eye on where copper is after the reaction, not before the reaction. And then you have to indicate the color. All right. Chemical formula. You know, if I have, for example, let me give you an example here on how you will say we started with copper, and after the reaction, the copper is in form of copper sulfide or copper 2 or copper 1 sulfide or copper 2 sulfide. Let me just indicate that. If I use this, or if this is in a chemical equation or part of the product, if this is one of the product in my reaction in a particular step, and then to answer the question such as this, I'll say, all right, after this reaction, copper is in solid state. So I'm just gonna write solid here, all right? I'll write solid. After the reaction, I'm just basing on the physical state given in the Palam's equation. The color, you have to watch the simulation. All right, you need to watch the simulation in order to do it, to state the color. Maybe this could be pink. I'm just picking up what is the color of the solution, or you know, it could be dark, it could be pink. Chemical formula, and then I'm just gonna write based on the cycle. Remember the cycle I showed you. You have to indicate this is not part of this is not part. So I'm just going to indicate. All right, I'm just going to indicate S here. This is S, and I'll just have to write chemical formula and then chemical name. This could be copper what? Copper, and please, there is, I see student missing points here. There is copper 1 and there is copper 2. This is copper 2, and then I'll say copper 2 sulfide. I'm just basing on what? I'm just basing on the example of the compound. Where is copper now? All right, it is in where is copper now? You don't need to fill in anything here. This question is answered by the information you key in here, that copper is in form of copper 2 sulfide. Copper is in form of copper 2 nitrate. Copper is in form of copper 1 oxide. You know, by looking at those individual equations, you should be able to fill in the table for 4.1. You'll do the same thing for 4.2. All right, 4.2. You have to read the pH. This will be on the PowerPoints as well. This will be in the PowerPoint slide, all right, which is given here in our simulation. Right here, the cast forming neutralization. There is the cast forming reaction. There is acid-base neutralization. You will watch this. The instructor will show you the pH range. You will have to indicate that on the data sheet. So every time you click the slide, there is an active YouTube you need to play in order to complete the data sheet, the composition. And then at the end, you will record the mass of the recovered what? Recovered copper, of which you have here mass of the evaporating dish. And after drying, all right, after drying, you need to find the mass of what? Mass of mass of copper recovered, final weight of recovered copper and evaporating dish. So if I know the mass of empty evaporating dish and mass of evaporating dish and copper, you can do the mass, subtract the weight to get the mass of what? Mass of copper recovered. You'll take note of this is the grounds, and the equation you use for this, as I said before, is this is recovered, all right, recovered over original, recovered over original times what? Times 100% to get the mass of copper um, recovered by taking it through the cycle, by taking it through the cycle. So I recommend that you read the material in TopHat to see where the equations are or how the equations look like to understand and state where copper is. To fill in the information regarding the color of the solution or of your product, you have to watch the simulation. Uh, with that, you shouldn't have any problem doing the calculation, turning the data sheet next week via Canvas. Before we break out for quiz, is there any question? Let me just stop sharing my screen here and see if someone has a question on the chat room. Let me see if someone has a question on the chat room regarding the experiment. Any question? Any question? If there is no question, I'll make the quiz available. It's right now 1:17, so for uh, 30 minutes, around 1:50. 1:50, we should be done. Okay, let's see. I'm going to make the quiz available right now. I'm going to make the quiz available. You need a calculator. You need a calculator in order to take the quiz. You will need a scratch paper. All right, you'll need a scratch paper and a pen. So I'll be on Zoom conference. Just in case you encounter any problem, just use the chat room on Canvas to send me a message. Other than that, thank you. I'll see you again next week. Hold on, let me make the quiz available.